Today I'll be talking, sorry about that. Today I'll be talking about my dissertation research that took place at the University of Glasgow during the summer of 2014 and a follow-up treatment that occurred at the Denver Art Museum just last year. So in the summer of 2014, I undertook basic textile research on the use of agarose gels. The process looked at 3 different research questions, including what effect does textile substrate have on the rates of diffusion and capillary action? How do different gel concentrations work on different fabrics? And what role does gel depth play in the effectiveness of a treatment? So 3 different fabrics were identified for this process. I looked at cotton, silk, and wool. I looked at agarose gels at 3 different concentrations, 1%, 2.5%, and 4%, as they were the most common that appeared in other textile treatments. And then finally, I looked at 2 different depths, 3 millimeters and 5 millimeters. So in order to undertake this, we stained all 3 different types of fabric using a stencil, using water-soluble dyes. The gels were cast into circular forms and applied to the fabric and weighted. In regard to the weights, this was done after a 4% test failed in terms of contact, because no contact was discerned and there was no removal of any of the ink into the gel. It was decided that the application of weight would aid in this. We later found that the application of slight finger pressure before applying the weight also helped with this, and you'll see more of that in the results. So these are the end results of the whole test. So to make things a little clearer here, on the right side of this is the 5 millimeter, on the left side is the 5 millimeter gels. On the right side is the 3 millimeter gels. Oops. The ones that are silk, our center is cotton, and the far side is wool. At the very top is our 1% gels, the center 2.5% gels, and the bottom is 4% gels. This is mirrored in the gels that are in the opposite photo. As you can see from this, the 1% gels were not as successful in the application. It caused very large ringing and tie lines on all fabrics and just wasn't going to work. Part of this was the application of weight, which did have an effect here, but the other part of it was that these fabrics were just having too much water applied, and it would just wick directly into the textile substrate. As you can see from the 2.5% gels, this was a much more effective situation. There was enough water to solubilize the ink, draw it into the gel, whilst reducing the amount of tide lining that occurred. The finger pressure came into play here in the center tests of those gels, where you see the cotton material, which is the center line, and all of a sudden those tide lines just disappear. That's after that finger pressure was applied. The 4% gels, you can see that there is removal, but it's significantly less than that of the 2.5% gel. So taking this information, it seemed very, very clear that we could transfer this into a treatment. So when the Denver Art Museum offered me this opportunity, I leapt at it. A sampler was identified in the collection that had been cleared for cleaning. This piece had a small disfiguring stain at one side, and it had been discovered that it was water soluble. So we did a quick drop test to see what was going on with the actual textile itself. The sampler is wool. It's embroidered using silk thread. It's an open weave construction, and it was also coated with some kind of starch or wax coating, which meant that there were other issues involved. So we've automatically increased our variables here. I don't have an even surface anymore, and I'm working with rather unknown issues. So based on the information that I had, I decided a 2.5% gel was our best option. It was going to introduce enough water to hopefully solubilize that stain, also get through the coating that we were working with, and because of the natural water resistance that wool has, hopefully would also retain a certain amount of that water and prevent any tide letting outward. So gel was applied for 15 minutes at a time to look at it, watch it, and I retained that same gel throughout the treatment until about 45 minutes in, at which point it was removed and a second one replaced. At this point, the deviation from the plan kind of went awry. The introduction of more water caused immediate tide lines to form. It broke out into the surface of the actual sampler. We immediately discontinued treatment, moved to a suction table, and completed the treatment under a little bit more control. So this just goes to show you the cutting out of the gels and how things are working here, as well as the end result of those gels. You can see there's some pull of the gel, of that stain into the gel, as well as my blotter that I was using on the suction table, and some other methods that I was using to kind of check. So here's the sampler after treatment. Not a whole lot of visual difference. However, there is some lessening of the stain, and I can honestly tell you that there was quite a bit of substance that was removed in the process. So what does this tell us? Textile treatments still remain difficult. The fact that we're working with a spun and woven structure with some sizing or no sizing means that we don't have the knowledge or the control over what's going to happen. We're wandering into territory that's kind of undefined. And there's many different characteristics that we don't quite understand yet. As it stands right now, I think these gels have great potential, but I'm not sure where they align with the textile treatment. I look forward to hearing where this can go, and I look forward to trying to find the ideal opportunity to utilize these gels. I want to thank everyone who's had a hand in this project, and thank you all.